Welcome to STEM Fair training for our new STEM Fair booklet and rules and regulations. It's a little different this year. The booklet will not be their main source of where they write information in. They will need to have a journal. The booklet will be a guide. Please review pages 1 through 5 with your students before you send the booklet home or begin your projects. This year it's a little bit different. On the bottom of page 5, you'll see that it says ask a question or define the problem. This year, as in future years, we have combined invention, innovation, and experiments all together. Page 6 of your book looks a little different than this page, but this represents page 6. I'm wondering, how far can a paper airplane fly? That's my beginning question. So now I have to brainstorm some things that I could change or vary. Now I need to write in my journal that it's today's date, the time that I'm doing this entry, and all of my information that I have started out with. That would include all of my brainstorming ideas that I've done this far and working on formulating my thing that I'm really wondering about. For the sake of time, I've already done this. They would be things like the size of the plane, the shape of the plane, the type of paper I used to fold that airplane, or adding weight to the folded airplane. Those are all things that I could change. Now I need to take that information and think about what kind of things could I actually measure or observe about each of those. And again, it's time to brainstorm and figure out what that is. Again, once I finish this part, I need to make another journal entry with the information that I've just come up with, all my brainstorming ideas. I need to include again the date and the time that I did this. As you can see, came up with ideas like the speed of that airplane, how high it flies to be measured, the distance it travels to be measured, or the time it stays aloft. All of these things are truly measurable items. I need to now choose which one thing in part A am I going to actually change. And then I need to figure out what one thing am I going to measure or observe once I've picked that item. This is where they'll go to the next section. I'll be continuing my journal entry again with adding my speed and height it flies, all the information I've come up with. Now I'm on page 7 of our little mini booklet. I'm going to identify my variables, and I've picked the type of paper that I'm going to use as my one thing that I'm going to change, and my one thing that I'm going to measure is going to be how far it travels, that distance. So I'm going to measure it in probably meters. Now I'm going to be moving more sticky notes. From this point on, we won't be writing any more new sticky notes. All we do is move the sticky notes to the new sections. I've done this with my class and they're really excited over it because it makes it really easier and streamlined. And I move my other sticky notes over to the things that I'm not going to change, so that this really gives the students an idea that what I will change will only be one variable, and that's going to be the paper I used. But the things that I won't change will be adding any weight to the plane. Another thing I won't change will be the shape of the plane or the size of the plane. Those are things I will never ever do while I'm working on this experiment. And things that I'm also not going to observe or measure will be the time it stays aloft, the height it flies, and the speed of it. The only things I'm going to change are going to be the type of the paper used and the distance it's traveled. These are it. And again, I'm going to write in my journal, date it and time. Now look at the bottom half of page 7 in your STEM booklet, and we're working on a testable question. Again, I just moved my little sticky notes over so that I know that when I change the type of paper, I'm going to figure out what happens to the distance it travels. And I have to write a guiding question, which my question is, what effect does the type of paper I use for making a paper airplane have on the distance it will travel? So I've refined what I had. And I'll be writing this in my journal. Next, I'll be writing down any prior knowledge I might have about airplanes. Like maybe I've learned something about resistance against the wings, or I know something about aerodynamics that I read about in a book before. So I'm going to list all my knowledge as well in my journal. And now we would be turning to page 8 in our STEM Fair booklet. And I'm going to list several predictions. And so now I have my couple of brainstormed ideas that I've written down, which is the lighter the paper, the farther the plane will fly. The heavier the paper, the farther it will fly. The paper won't make a difference in how far it will fly. So just some brainstorming ideas, again, writing them in our journal so that now I can create my hypothesis. And if you look at page 8 in your booklet, it says in there a great description of how to come up with your hypothesis. And it must be in an if-then statement. So if I use the heaviest paper, then my airplane will fly the farthest distance. Now you're going to be on page 9 in the booklet, and in their journal they're going to start listing their materials, and they may need to add to it later if they've forgotten something. They're going to set up their conditions as well, and this is also where they're going to either draw a prototype or to list the exact steps and directions that they did, or both of those items, so that we really have a good idea of what they're doing. This is a critical step in their journals. Now on to page 10. Again, I'm just moving the sticky notes in the journal, and I know the one thing that I will change is going to be the type of paper. This is my independent variable. And then I'm going to be writing in my journal the same thing, as well as what I'm going to do to carry out the change. I'm going to explain it. Number of trials that I must conduct. They must have 5 trials to move on to district level. If they do not have 5 trials or 5 samples that they've done, it will not be able to go on to the district level. And the data that they will be collecting will be the distance. So they're actually going to be, if this was their experiment, they would be throwing the airplane and then measuring the distance. And they need to collect 5 trials from each different type of paper they chose. In this experiment, what I chose was to use newspaper, copy paper, regular notebook paper, and cardstock, and find out which one flew the farthest. And then I have to record each one of those in a table. On page 11, again, they're going to move their sticky notes over. So when I change the type of paper, I will be measuring the distance it travels. This is what I'm going to be collecting. Now, this is a generic data table. This is not the table that they have to use. The table may change according to whatever it is that they're collecting data on. If you noticed, I had mentioned I had 4 types of paper, and there's only 3 on this data table, so I would have to extend it if I were using it, and I would only be having to make 5 trials. After they have collected their data, we're going to move on now to page number 12. And again, they're moving their sticky notes. And this makes it really easy so that they know which is their x-axis and which is their y-axis for information. What I'm measuring is going to go on the y-axis. So if I measured the distance it traveled and it was 25 meters on average, I would be making my first y-axis one on the 25 meters. And the x-axis is going to have, for me, I'm listing my 4 different kinds of paper. So there's going to be one section that has the newspaper and its measurement. There's going to be one section for the copy paper. There's going to be one section for the cardstock and one section for the regular notebook paper. So I would have a bar graph that I would be using for this one. Again, different types of graphs. And if you go to our Deer Park website, under student links, under the math section, there's a link to create a graph where they can create any of the type of graphs that they might need. So this is accessible by both home and at school just through the student links on our Deer Park website. Pages 14 helps us to draw our conclusions. Again, they're going to be writing it in their journals. Make sure they date it and put their name or their time that they're doing it on it. Page 15 helps them figure out their abstract. And page 16 gives them the layout that is expected on their backboard. And again, if they are going onto the district level, a backboard is required. They may use another presentation method electronically, but know that there is no electric supplied to them, so whatever they're presenting, they have to have their own supply of electricity if they would move on to the district level. But they will be required to have a backboard as well. We have backboards down in the River Otter Pod for $5 each. You can send students down in the morning or just put money in a box with the student's name, and we will have them deliver it to your classroom. If you have any questions, if you're a student watching this, please refer them back to your teacher. If you're a teacher, please feel free to contact me, Beth Brewster.